Hello, welcome. Now today I want to show you something very interesting. All right. Now this is a cup of water. Okay. Now if I spill this water on the floor, what do you think is going to happen? Now the water is going to gather into small drops. Small drops. All right. Now if, for instance, let's assume I have kerosene here. If I spill the same kerosene on the floor, what is going to happen? The kerosene is not going to gather into small drops like water. No. The kerosene is going to spread across the surface of the floor. Now, why is it that the water will gather into small drops, but the kerosene is going to spread across? Do you know why? Think about it for a second. Now, let me give you another analogy. Now, let's still retain this in pool of water. Now let's assume I have a needle or a blade, a razor blade, okay? And I carefully place that needle on the surface of this water. What do you think is going to happen? Is it going to sink? No. Is it going to float on top of the water surface? Yes. But you're going to ask me, the needle is a solid and it's denser than the water. Why is it not going to sink? That is what I want to show you in today's class. You see, many times the surface of the water acts like a skin that is stretched, and that's because the molecules of water are only pulled downwards and sideways, causing the surface of water to act like a tightly stretched skin. Okay, now that force that causes the surface of the water to act like a tightly stretched skin is what we are looking at today. It is called surface tension. All right. So I said surface tension is defined as the force per unit length. Force per unit length on either side of the imaginary line drawn on the liquid surface at rest. So the force per unit length is the surface tension. Now it is a vector quantity. Take note of that, JAM students. A vector quantity meaning it has both magnitude and what? Direction. And measure the Newton per meter. So the SI unit of surface tension is Newton per meter. So surface tension mathematically is represented as what? Force in Newton over length in meter. Now let's take a question. Question 1. A force of 0.072 Newton acts along the surface of water over a length of 0.03 meter. Calculate the surface tension of the water. Now, first thing first, like I said, you bring that to your what? Parameters. All right. Now, force of 0.072 Newton, so my F is 0.072 Newton. All right. Act along the surface of water over a length of 0.03 meter. My L is 0.03 meter. Now calculate the surface tension. Now surface tension is what I don't know. All right, unknown. But I know that surface tension, ST now for short, is equal to what? Force over length. F over L. What is my F? 0.072 Newton. What is my length? 0.03 meter. So why don't you try this and let me know your answer in the comment section. 0.072 over 0.03. Let me know in the comment section. Bye.